class we have discussed about the binomial distribution wherever the experiment has fixed number of outcomes and if the experiment is repeated for some fixed number of trials. But when the experiment is repeated for several number of times here, then it is means the binomial distribution has failed to calculate the average of that experiment. Then automatically under the three conditions the binomial distribution tends to the Poisson distribution. So here the first condition is that the number of trials are indefinitely large. That means the number of trials means n when n tends to infinity, right? Then when the number of trials are indefinitely large, then the probability of success also becomes 0. It has no value. So p tends to 0, and also the mean of the binomial distribution is finite. That means np value is finite here. Then under these three conditions automatically the binomial distribution tends to the Poisson distribution. So where we can apply this Poisson distribution? So let us consider here on a road where several vehicles are traveling here. So during the particular interval of time how many vehicles have passed, then what is the average rate of accidents during a particular day or during a particular week or during a particular period of time. So for that we can calculate, or also we can find the average number of SMS sent during that particular interval of time or sent during only Facebook, Twitter or WhatsApp. So not only that, also we can calculate the average number of emergency calls received in a hospital, right? So wherever we need to find the average rate of experiment when the number of trials are large in number. Apart from that, the Poisson distribution is also useful to predict the earthquakes, right? So there also we can use the Poisson distribution here. So let us see that example here, the number of cars are passing, right? So during that particular interval of time, how many cars have passed and what is the average rate of experiment? So remember here, the number of trials are indefinitely large, but whereas in the binomial distribution, only we can consider a random experiment which has fixed outcomes like the quality of a product, tossing a coin, throwing a die and all. But here if you consider the data for some 100 days also, for those 100 days we can calculate the average rate of that particular incident, right? Then number of telephone calls received in the particular day or in the particular month, so that also we can calculate. And apart from that also the Poisson distribution is useful to just calculate that radioactive substances, the average rate of the radioactive substances here. So if you see the probability mass function of Poisson distribution, it is given as here e power minus lambda into lambda power x by x factorial. So this is the only one discrete distribution where here we can take the random variable from 0 to infinity. The rest of all discrete distributions are defined here, means the limit is defined. But for this Poisson distribution the limit is not defined and also the outcomes are not defined here, right? So that's why we are calculating e power of minus lambda, where lambda is known as the parameter of Poisson distribution. And also this is the only one discrete distribution for which both mean and variance are equal, right? And also we can find the number of printing mistakes in a particular book, not only for page, we can find in a particular book also. So if you see the example, so the mean is here lambda and variance is also lambda. If you see that examples here, the number of defective electric bulbs manufactured by a reputed company, the number of telephone calls per minute at a switchboard, the number of particles emitted by a radioactive substances, the number of printing mistakes per page in a large text. So there we can apply this Poisson distribution. Now let us see one problem on this. A car hire firm has two cars which it hires out day by day, right? So it has only two cars. The number of demands for a car on each day is distributed as a Poisson distribution with mean lambda. So remember here in the Poisson distribution problems always they will mention the average rate of that experiment. Whereas in a binomial distribution they will just mention the probability of success or probability of failure, like probability of defective or probability of non-defective. But here in the Poisson distribution always they will mention the mean rate of that corresponding experiment. So here it is given that it is 1.5. So calculate the proportion of days on which there is no demand, means there is no car hiring on that particular day, on which demand is refused, right? So here lambda is given as 1.5. So our probability mass function is e power minus 1.5 into 1.5 power x by x factorial. So on which there is no demand means here, let if x represents the demand of car, then x equal to 0, right? So it is 0.2231, right? So e power minus lambda you have to obtain in the calci by using shift ln power symbol. So there if you apply that operation, we will get directly that e power minus 1.5 value, and 0.5 1.5 power 0 is here 1 only, and anyhow 0 factorial is 1. So the probability that there is no demand of cars is 0.2231. Then the next you have to find is on which demand is refused. When the demand is refused here, when there are more than 2 hirings are there, because it has only 2 cars, right? That means probability of x greater than 2 you have to find, not exactly 2, x greater than 2. Now here the random variable is defined from 0, 1 to so on infinity. So it is highly impossible for us to calculate probability of x equal to 0, x equal to 1, x equal to 2, so on till infinity, right? So for that we will consider the formula 1 minus probability of x less than or equal to 2 here. So that is nothing but 1 minus probability of x equal to 0, x equal to 1 and x equal to 2. So if you consider the equation in the calci, there you can obtain probability of x equal to 0, x equal to 1 and x equal to 2 here. So it is 0.1913 here. So they have asked the number of days, right? So number of days in a year is 365. So 365 into the corresponding probability 0.1913 is here 70 days, right? So 70 days they can refuse the demand of those cars here. So like this we can solve the problems on Poisson distribution. Some more problems are there, we will discuss in the next class.